This problem 636, again, Klein problem. This is a little bit different, okay? So let's read the problem. For the following mechanism, identify the sequence of arrow pushing. So in this case, the arrow pushing is already given to you, and all you're being asked is, okay, what's going on? Name the steps, okay? And it's kind of important to name them also. So when you're writing the mechanism, you can actually say these things and then they mean something to you, okay? And then you will not go wrong. All right, so it's kind of important, like when we do our reactions in organic chemistry, that we kind of talk our way through this, okay? And you should do this too without feeling that you're going crazy or something. You should definitely talk while you're doing the mechanism. All right, so let's take it step by step. So we are going from molecule number 1, then 2, 3, 4. So we have a lot to cover in this one also. So 6, 7, and then finally 8. So we have 8 molecules, and so we have 7 steps to talk about over here. So the first step, okay, that we have going for us is, let me get my correct pen. Okay, let me get a different color, purple. Okay, there's purple or green. Let's do green. Anyhow, okay, so going from step number 1 to 2, you can see that the oxygen, which is the nucleophile, is picking up a proton, okay? Because why? HA is generally an acid. So if it's an acid, acids are going to be electrophiles. So which means that the first step is what we call a proton transfer. It's up to you if you want to write the dash or not. Let me actually remove it, okay, so it doesn't cause any problem, and I'll change the pen size also because I think it's coming too thick. All right, so here is it's a transfer and it's a proton transfer going on, okay, in the first one, because the nucleophile is just picking up a proton. Now, in the next one, there is no protons involved. If you look at that, you have the oxygen doing the attacking, and then you have the electrophile here. How do you know the electrophile is here? Because the nucleophile is attacking this carbon. So if it's attacking this carbon, that must be then the electrophile, okay? So which means that this is just a simple nucleophilic attack. So I'm just going to write it like this in a short form. So it's just a nucleophilic attack, nucleophile attacking the electrophile. Okay, so this is the nucleophile here. I am labeling everything for you so that way you know, but you don't have to label all these things. Sometimes you just have to tell what is happening. So really you have to just write, that you have a proton transfer or then a nucleophilic attack. That's the important thing. So then in the next one, what is happening? You have A, which has the lone pair of electrons. And this A is picking up a proton, which if you see the second arrow then, so these electrons are now being left on the oxygen. So this one is going to be then a proton transfer, because A is picking up the proton, is picking up a hydrogen. Now remember, we call it a hydrogen, but it really is a proton. Why is it a proton? So we call it a proton transfer because you're only taking H plus. Hydrogen would be this and hydride would be H minus. H minus means that you're taking a hydrogen with its electrons. Proton means that you're taking an H without its electrons, okay? And how do you know it's without its electrons? Because right here with this arrow, you can see that it's leaving its electrons on the oxygen, okay? That's why only a proton is going. That's why we keep calling it a proton transfer. Okay, so what is the next one now? So if you look at step number 4 to 5, you can see that the alcohol group over here is picking up a proton. So again, this is a proton transfer. Oxygen with the 3 bonds, it's called an oxonium ion. So again, we formed an oxonium ion. Okay, so usually the only oxonium ion you have seen so far is H3O plus, okay, which is the hydronium ion. So that's kind of what it looks like. And you've done this in Gen Chem 1 and 2, primarily 2. So an oxonium ion, hydronium is an oxonium ion also, okay? But anyhow, so then let's see what's happening from number 5 to 6. So number 5 to 6 is actually an internal transfer going on, and it's not really a transfer going on. You're actually getting rid of water. right? So this says minus H2O, so which means all of this is leaving, okay? So this is a loss of a leaving group. And what is the leaving group here? The leaving group is water, okay? So it's all going away. So the leaving group is leaving, okay, as we say it. So in case of these kind of things, you know, where you have a leaving group going, you have to have either something that is negative or something that is neutral, okay, that is going away. So it depends on the reaction. Usually a positive thing is not going to leave. A positive thing is going to get picked up, like the proton transfer. Okay, so that gets picked up, but usually you have a leaving group as in a negative or a neutral molecule. Okay, so this is loss of a leaving group happening from number 5 to number 6. Then let's look at number 6 to 7. And then here you see that oxygen is attacking this electrophile now. And in this electrophile, actually, let me go back one step. Okay, just one quickly over here, because you actually have 2 arrows in this one. Okay, so let me show you the other arrow. This is the other arrow, right? That is how we got this oxonium ion, because electrons are being pushed from oxygen onto the carbon. Okay, over here onto the bond with the carbon. That's how you got this double bond. Okay, with the oxygen. So, but that is really not the main reaction. The main reaction that's happening, or the one that you should label, is the loss of the leaving group. Okay, so I just wanted to mention that so you don't think that I'm ignoring this. Okay, I know that this is pushing electrons into the carbon. Okay, so now going from number 6 to 7, I'm back again. And so now this oxygen, which is the nucleophile, is attacking the electrophile, which is the carbon. Okay, and why is this carbon the electrophile? Because that is the one that has oxonium ion on it. So oxonium ion cannot accept any more electrons, like as in this oxygen will not attack this. Okay, that's never going to happen. So otherwise oxygen is going to have too many bonds. Okay, so that doesn't happen. So the carbon next to that oxygen actually is the one that gets attacked. And so now what you're going to have is that oxygen attacking. So what, let me erase all of this. Okay, so what is happening here is just a nucleophilic attack. And I don't know what Klein calls it, but this is what I will call it, and I will accept this. Okay, and I hope that he has that also in his book, and I will check that. Okay, but anyhow, so it's a nucleophilic attack that's going on. And now let's go on to number 7 to number 8, because now we are on number 7, where in the nucleophilic attack, you have the oxygen bonded to the carbon. So the oxygen bonded to the carbon is now going to be this one. Okay, because remember in the second arrow, what happened? The second arrow took the electrons from the oxygen and from the double bonded oxygen and put them on oxygen, which is now this one. Okay, things get moved around. You know, when we do mechanisms like this, the atoms will not be in the same place where you see them before. Okay, so you kind of have to learn to recognize that slowly, it's going to happen. Okay, so then the last step going from 7 to 8 is you can see that here, going from this number 7 to number 8, you lost the proton. So again, you had A come in and pick up the proton. And so which means this is going to be a proton transfer. Okay, so let me write that as well. So H plus transfer. Okay, so A is picking up this proton, and the proton then leaves its electrons on the oxygen. So it's really a whole series of proton transfer, nucleophilic attack, you know, and so on. So that is how mechanism works. And we talk like this also in class. Okay, so when I teach you all these things, I will just keep saying, okay, here's a proton transfer, there's a nucleophilic attack, there's a leaving group going, you know, these are the terms we use all the time. Okay, so kind of get used to it. Now, I know this was a huge mechanism, but I thought, you know, if I take too small, then you will think that, oh, I just covered only 2 things in there. Okay, but this is a whole big thing. So pick up whatever you can from here, and hopefully you understand that part. Okay, all right.